Hi everyone, welcome to my channel Edu-spectra. So now today let us start the next topic, which is remainder theorem. Okay, so let's see what does the theorem says to us. Okay, so the theorem says let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder will be equal to p of a. Okay, so basically in our previous video we had done a long division method and found out a remainder and all. But here in a remainder theorem they are telling you a much more simpler way by which you can find the remainder of a particular polynomial. Okay, you may not understand what does this sentence mean. Okay, so let us understand this theorem with the example number 9. Okay, let us understand it with the question. Now the question, your example number 9 is find the remainder when x raised to 4 plus 3x cube minus 2x square plus x plus 1 is divided by x minus 1. Okay, so here we know by using the long division we know how to find the remainder. Now in a remainder theorem always look at the divisor. Okay, always look at the divisor. Here our divisor is what? X minus 1, isn't it? Our divisor is x minus 1. Now they are telling, now in a remainder theorem they are telling to consider this divisor as x minus a. Okay, if p of x is divided by the linear polynomial x minus a, this is the polynomial and we are dividing it with x minus a. Okay, so when we divide it with x minus a, so we will be getting x minus a is equal to x minus a. Now from here we can find the value of a, right? Now what is a over here? A will be this 1. Okay, you should not consider the negative sign. So from here we will be getting a is equal to 1. Otherwise also you know x minus 1 you can equate it to 0. From here also you will get x is equal to plus 1. That is it. So x minus a means we should take this a is equal to 1 over here. Now then they are telling that if we substitute this a is equal to 1 on this polynomial given to you, we will get the value of our remainder. Okay, so let's see, which means they are telling us to consider this first one, the dividend as p of x. So we are having p of x is equal to x raised to 4 plus x cube minus 2x square plus x plus 1. Now what should we do? We have to find p of a, isn't it? Now here what is the value of a given to you? 1. Okay, we found the value of a as 1. So we have to do p of 1. Okay, so when we do p of 1, we will get 1 raised to 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. Okay, now you should solve this. 1 raised to 4 is 1 plus 1 cube is 1 minus 2 plus 1 plus 1 2. So here also 1 plus 1 2 minus 2 plus 2, 2 minus 2 is 0, and finally we will get it as plus 2. Okay, so this will be the remainder that you will be getting when you divide this number by x minus 1. Okay, this is exactly what the remainder theorem says. Okay, so I hope it is clear. When we substitute the 1 over this p of x value and we put the 1 in place of x over here, the value that you are getting will be the remainder. Okay, that is exactly what the remainder theorem tells you. Okay, so just substitute and find your answer. Okay, so now let us do our example number 10 also to understand it much more better. Okay, so before that let's see the proof of remainder theorem also. Okay, usually it's not asked for exam, but okay, let's see. So now let's see the proof of the remainder theorem. So we are proving this remainder theorem with the note that we have written in a previous class. Okay, in a previous class we had written dividend is equal to divisor into quotient plus remainder. Isn't it? If you remember, we had written dividend is equal to divisor into quotient plus remainder. Okay, so here first step that we should do, dividend in our remainder theorem, they are telling you we have to take it as p of x. So I am writing p of x over here is equal to what was your divisor? The divisor, we are dividing it by the linear polynomial x minus a. So I am taking divisor as x minus a over here into. Okay, so we took it like this. According to the remainder theorem, then when we substitute this x with this a, we will be getting the remainder. So what should we do? In place of this x, substitute a. So I will get p of a is equal to, here also in place of x, substitute a. So I will get a minus a into quotient plus remainder. So from here, p of a is equal to, what is a minus a? 0. So 0 into quotient plus remainder. So from here I will get p of a is equal to 0 into anything is 0 itself. So what is left with me? Which is your remainder. So from here I will be getting p of a is equal to remainder, which is exactly what the remainder theorem tells you. Okay, so this is the way in which we prove the remainder theorem by our equation dividend is equal to divisor into quotient plus remainder. Okay, I hope it is clear. So now let's move on to our example number 10. The question is, check whether the polynomial q of t is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. Okay, this is the question. Now, before doing this question, we should understand what does the word multiple and factor means. Okay, for example, when I am doing 12 by 6, we can, when we do 12 by 6, we know here you know 6 2s are 12. So when you do the division, we will be getting a remainder equal to 0. Why? Because this 6 and 12 are perfect factors of each other. So when you see over here, we will call this 12 as the multiple of 6 and the 6 as the factor of 12. Okay, that means we can, when we do 12 by 6, it is perfectly divisible with each other, and finally we will be getting the remainder equal to 0. This is the example of that. So now here the question is asking you, check whether the polynomial is the multiple of the given quantity. So whenever they ask you whether it is a multiple or whether something is the factor of something and all, we have to prove that the remainder of this fellow is equal to 0. Why? If the remainder becomes 0, we can say that these two are perfectly divisible with each other, and definitely this will be the multiple or this will be the factor of each other. Okay, so here our main task in this question is to show that the remainder is equal to 0. Now how will we find the remainder? By using a remainder theorem. Okay, so here we are dividing this 4t cube with this number. Okay, so first of all, according to our remainder theorem, okay, what should we do first? We have to first find x minus a. Okay, so when we find x minus a, what should you do over here? Here we are having 2t plus 1, isn't it? Having 2t plus 1. So just take this 2t plus 1, equate it to 0, find the value of t. So from here we will get t is equal to minus 1 by 2. Isn't it? When we do, this goes to the other side and this comes to division. So we will be getting t is equal to minus 1 by 2. Okay, here t means this is of the form x minus of minus 1 by 2. Isn't it? So that is the mean. X minus a means x minus of minus 1 by 2. This is the a term. So we got a is equal to minus 1 by 2. Or now what should we do? We should substitute this value of this t that you have got, t is equal to minus 1 by 2 in the q of t. Okay, so let's substitute and see. So when you substitute, t is equal to minus 1 by 2. So you will be getting q of minus 1 by 2 is equal to 4 into minus 1 by 2 the whole cube plus 4 into 1 by 2 the whole square minus 1 by 2 minus 1, isn't it? So from here, when you if you see 4 into minus 1 by 8 plus 4 into 1 minus plus 1 plus 1 by 4 minus 1 by 2 minus 1. Okay, so this you can cancel off. Here you will be getting 1 by 2. Here also this 4 and this 4 you can cancel. Now further when you do, we will be getting over here as minus 1 by 2 plus 1 plus 1 by 2 minus 1. Okay, these are just opposite to each other. So when we do, we will get the final answer as 0. Isn't it? These both will cancel off. Okay, so finally we got the value equal to 0. Now what is this? This is your q of minus 1 by 2. So we know according to remainder theorem, if this value of q of t is equal to a, then definitely this will be this value that you have got will be the remainder when we divide these two. So now since we got our remainder equal to 0, we can say that these two numbers, okay, so we can say that the polynomial q of t is a multiple of 2t plus 1. Okay, just we have to show that the remainder when we do or when we find out the remainder, it will be equal to 0. Okay, that is the main concept over here. I hope it is clear to you. Okay, so now let's move on to our exercise number 2.3. The question is find the remainder when x cube plus 3x square plus 3x plus 1 is divided by the following. Okay, so the first one is x plus 1. Okay, this question you can either do by the long division or by using your remainder theorem. Either way you will be getting your answer. So I will be doing it using remainder theorem. Okay, so let's see. So what should we do first? First we should find x minus a. So when we so for x minus a, right, x plus 1 is equal to 0. From here you will be getting x is equal to minus 1. Okay, so our x minus a will be x minus of minus 1. Okay, now from here what should you do? Our x is equal to minus 1. So in order to find the value of the remainder, substitute this minus 1 in place of x over here. Okay, so you will be getting minus 1 the whole cube plus 3 over here, isn't it? Okay, so minus 1 plus 3 is 0 and minus 3 plus 1 again, these are just opposite to each other. So these both will cancel off and you will be getting an answer equal to 0. Okay, so from here you can write the value of the remainder is equal to 0. Okay, I hope it is clear. Okay, so next one is x minus 1 by 2. So first of all we have to find x minus a. So x minus 1 by 2 is equal to 0. So from here you will be getting x is equal to 1 by 2. So our x minus a will be what? It is equal to x minus 1 by 2. Now what should we do? The value of x that you got, we have to substitute in place of this x. So we will be getting 1 by 2 the whole cube plus 3 into 1 by 2 the whole square plus 3 into 1 by 2 plus 1. Okay, so when we do, we will be getting 1 by 8. This you will be getting 1 by 4 over here. Multiply 3 plus 3 by 2 plus 1. Okay, isn't it? So now after writing this, we have to find what? We can either do cross multiplication or we can find the LCM. Isn't it? So when we do the highest denominator, the highest number in the denominator usually will be the LCM of them. So when we take 8, okay, so after finding the LCM we will be getting 1 plus 6 plus 12 plus 8 by 8. Okay, so when you add all these numbers we will be getting 27 by 8. Okay, so this will be the value of your remainder. Okay, I hope it is clear. So now the third one is a much more simpler question that you can take it as a homework. There the value of a will be equal to, you can write it as x minus 0. So your value of x will be, x is equal to, you will be getting 0. So substitute 0 in the equation and find the remainder. You will be getting the answer as 1. Okay, you get the remainder equal to 1. Okay, that is the answer. You can just write out and see. Okay, so now we will move on to the fourth one. So next one is x plus 5. Okay, first of all find x minus 8. So first of all take x plus 5, equate it to 0. So you will be getting x is equal to minus 5. Just substitute this minus 5 in the above equations. So minus 5 the whole cube plus 3 into minus 5 the whole square plus 3 into minus 5 plus 1. Okay, so when you do, you will be getting minus 5 cube plus 3 pi square minus 3 pi plus 1. Okay, so this will be the remainder. Okay, now you cannot do any further simplifications. Okay, so this is your answer. Okay, so our next one is 5 plus 2x. So first of all we have to write 5 plus 2x is equal to 0. So from here you will be getting 2x is equal to minus 5 and x is equal to minus 5 by 2. Okay, this is the A. So now substitute this minus 5 by 2 in this equation and find the remainder. So minus 5 by 2 the whole cube plus 3 into minus 5 by 2 the whole square plus 3 into minus 5 by 2 plus 1. Okay, so when you do, you will be getting minus 125 by 8 plus 3 into 25 by 4. Okay, 2 square 4 minus 15 by 2 plus 1. Okay, so 3 into 25 it is 75. We can take again the LCM. Always the highest denominator will be usually the LCM. So you can take 8 over here. I took the LCM over here. So when we solve this, we will be getting 158 minus 185 divided by 8. So 158 minus 185 is equal to what? Minus 27 divided by 8. Okay, so this will be your remainder, minus 27 by 8. Okay, you can make a note of it. Okay, so our second question is find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Okay, so here also first of all find the value of a. So take x minus a, equate it to 0. So from here we will be getting x is equal to a. Now substitute this value of a over this equation that you have got. So from here you will be getting a cube minus a into a square plus 6 into a minus a. So a cube minus a cube plus 6a minus a. A cube minus a cube is what? 0. Plus 6a minus a is what? 5a. So the final answer will be 5a. So this will be your remainder that you will be getting. Remainder is equal to 5a. Okay, I hope it is clear to you. Okay, so our next question is check whether 7 plus 3x is a factor of 3x cube plus 7. Okay, so a similar question here done in our example also. So I have told you in such type of question where they are given it is a factor or a multiple, we have to show that the remainder will be equal to 0. So first of all let's find the remainder. So from here take 7 plus 3x equal to 0. So 7 is equal to minus 3x or x is equal to, you will be getting it as minus 7 by 3. Okay, this you have to substitute in your this first equation. So you will be getting 3 into minus 7 by 3 the whole cube plus 7 into minus 7 by 3. Okay, so when you do 3 into minus 343 by 27 plus minus 49 by 3 when you do it. Okay, so you can cancel this 3, you will be getting 9 over here. So you will be getting minus 343 by 9 minus 49 by 3. Okay, so if you take the LCM it will be 9. So getting, so when you do this plus minus, so you will be getting final answer as minus 490 by 9. Okay, so this will be your remainder, minus 490 by 9. So what do you observe over here? Here we see that the remainder that we have got over here is not equal to 0. Okay, since the remainder that we have got is not equal to 0, 7 plus 3x is not the factor of 3x plus 7x. So since it is since we didn't get the remainder equal to 0, we cannot say that these two polynomials given to you are completely divisible with each other. So 7 plus 3x is not a factor of 3x cube plus 7x. Okay, I hope it is clear to you. Okay, so I hope all the things that we have discussed in today's class is clear to you. So now let us meet in our next video with a new topic. Thank you. Please like, share and subscribe the channel.